This is the $55,000 drone that's crippling Russia's entire war machine. It's not stealthy, it's not high-tech, and it's definitely not pretty. But Ukraine's FP1 has quietly become one of the most devastating weapons of the war, striking oil refineries, airfields, radar stations, and factories deep inside Russian territory. Cheap, fast to build, and nearly impossible to stop, the FP1 is being produced at a rate of 200 a day, giving Ukraine more long-range strike power than most NATO countries combined. The FP1 represents a major shift in Ukraine's military capabilities, one that could cripple Russia's war effort. It clearly demonstrates how powerful a long-range strike drone can actually be. Let's find out why. Traditional military doctrine assumed that deep strike weapons needed to be sophisticated, precise, and survivable. This led to systems like the Tomahawk cruise missile, which costs roughly $2 million per unit and incorporates advanced terrain-following radar, GPS, INS navigation, and hardened electronics resistant to electronic warfare. The logic seems reasonable at first. If you're going to strike targets hundreds of miles behind enemy lines, you need weapons that can navigate complex routes, evade air defenses, resist jamming, and reliably hit their targets. This naturally drove costs upward, as engineers added layer upon layer of capability to ensure mission success. But Ukraine's experience with the Iranian-designed Shahed 136 that Russia deployed revealed that modern warfare doesn't rely on who has the most money to spend on a single missile, but on how many low-cost ones can be launched as quickly as possible. So, in high-intensity conventional warfare, simplicity might actually be more effective than sophistication. The Shahed costs between $20,000 and $50,000 to manufacture, yet the West would need to expend million-dollar interceptors to shoot them down. Even when Ukrainian forces successfully defended their cities, they were losing the economic war with every engagement. Ukrainian engineers at Firepoint recognized that this same principle could work in reverse. If Russia was bleeding Ukraine's air defense budget with cheap attack drones, why couldn't Ukraine bleed Russia's military-industrial capacity with equally cheap strike platforms? The answer became the FP1, and the design philosophy behind it reveals why sometimes less truly is more. Firepoint made a crucial decision that separated the FP1 from competitors like the Lyuty drone. While the Ukrainian defense industry, or Ukroboronprom, initially pitched the Lyuty as a multifunctional platform that could serve both as a suicide drone and as a reusable reconnaissance UAV, Firepoint designed the FP1 from the start as a single-use strike weapon. This distinction might seem minor, but it changes everything about how the drone is built. A reusable reconnaissance platform needs to survive hundreds of flight hours. It requires durable materials, robust construction, sophisticated systems that won't fail over time, and careful quality control to ensure reliability. Think of it as the difference between a ceramic coffee mug and a disposable cup. One needs to last for years, the other just needs to work once. By accepting that the FP1 would only complete a single mission, Firepoint could strip away every component that didn't directly contribute to that one task. The result is a production process that seems almost absurdly simple for a weapon system capable of striking targets over 1,000 miles away. The journalists who visited Firepoint's production facility in December 2025 describe what they saw as revolutionary in its simplicity. The fuselage isn't carefully cured composite material, but vacuum-formed plastic. The avionics bay isn't a precisely machined aluminum housing, but laser-cut plywood. The fuel tank is a simple plastic. The engine is literally a small moped motor, the kind you could order from a commercial supplier. The wing and tail mount on 6 carbon rods and connect to the fuselage using tie straps, clamps, and rubber bands. It all sounds like something built in a garage workshop, not a military production facility. But that's precisely the point. By using off-the-shelf components and simple assembly techniques, Firepoint created a drone that can be manufactured in 3 days by workers who don't need years of specialized training. Compare this to Western cruise missiles, which require months of production time, specialized facilities, and workers with security clearances. But here's where the story gets even more interesting. While the FP1's physical construction is deliberately primitive, the software and guidance systems are among Ukraine's most advanced on offer. Out of Firepoint's 3,500 employees, approximately 650 are engineers, many of them demobilized veterans who specialize in electronic warfare resistance and strike mission planning. The company reportedly spends around $4.75 million per week across all research and development programs. This creates a fascinating hybrid, a drone with the physical complexity of a large model airplane, but the navigation and guidance capabilities of a modern cruise missile. The FP1 can fly complex routes, resist Russian electronic warfare, and reliably strike distant targets despite being held together with what amounts to zip ties and duct tape. It's a testament to how much modern military capability lives in software rather than hardware. The production numbers are also remarkable. With a manufacturing rate of 200 drones per day, Firepoint produces more long-range strike platforms in a single month than many countries acquire in years. For context, the United States currently has the capacity to produce around 50 Tomahawks per month, with the actual procurement being significantly lower at about 40 to 60 missiles per year. But Firepoint churns out 6,000 FP1 drones monthly. This isn't just a different order of magnitude, it's a completely different approach to military production, one that prioritizes mass over individual platform capability. And when you examine the strategic implications, the logic becomes clear. Let's do some simple mathematics so you can understand just how little budgeting this weapon needs. At $55,000 per unit and a production rate of 200 per day, Firepoint can manufacture $11 million worth of strike capability daily. Over a month, that's $330 million in long-range attack drones. Over a year, it's nearly $4 billion in strike platforms rolling off Ukrainian production lines. Now compare this to Russia's air defense costs. A Russian S-400 missile costs approximately $2 to $6 million, depending on the variant. Even if we assume the cheapest S-400 interceptors at $2 million each, Russia needs to spend $40 worth of air defense for every $1 worth of Ukrainian drones. And that's before accounting for the radar systems, launchers, transport vehicles, and train crews needed to operate S-400 batteries. But it gets worse for Russia. The S-400 isn't optimized for shooting down small, slow-moving drones flying at low altitude. It's designed to engage fighter jets, cruise missiles, and ballistic missiles at high altitude and long range. Using an S-400 to shoot down an FP1 is like using a sledgehammer to swat flies, except the sledgehammer costs millions of dollars and you have a warehouse full of flies. Russia's actual defense against the FP1 relies on a layered system, including electronic warfare, shorter-range air defense like the Pantsir S-1, fighter aircraft on patrol, and even machine gun teams trying to shoot drones down manually. Each layer costs money and requires personnel. Each engagement, whether successful or not, consumes resources that Russia must replace. And here's where Ukraine's strategy becomes truly ingenious. By producing 200 FP1 drones daily, it can sustain an offensive pace that simply overwhelms Russia's defensive capacity. Even if Russia shoots down 90% of incoming drones, which is an optimistic estimate, that means 20 drones per day still reach their targets. That's 600 successful strikes per month, hitting Russian military infrastructure, oil refineries, ammunition depots, command centers, and logistics hubs. The strategic targeting of Russia's energy infrastructure reveals the full scope of what Ukraine is accomplishing. Remember, about 60% of all strikes are conducted by FP1s alone, so a majority of the newsworthy strikes could have happened due to this simple drone. And the extent of the damage is nothing short of amazing. According to multiple Ukrainian military sources, long-range strikes have severely damaged Russia's oil and gas refining capacity throughout 2025. Refineries in Ryazan, Tuapse, Nizhny Novgorod and multiple facilities in Tatarstan have all sustained repeated attacks, Each strike doesn't just destroy physical infrastructure, it forces Russia to divert resources to repairs, increases insurance costs, disrupts supply chains, and sends signals to global energy markets that Russian production capacity is vulnerable. Let's put this in economic terms. Russia's oil and gas exports generate roughly $200 billion annually, accounting for about 40% of the federal budget. Refining capacity directly impacts how many refined petroleum products Russia can sell, and refined products command higher prices than crude oil. Every percentage point of refining capacity that Ukraine eliminates translates to billions in lost revenue. Ukrainian strikes have reportedly reduced Russian refining capacity by an estimated 10% from pre-war levels. This represents potential annual losses of $20 billion in refined product exports. Even more significantly, the constant threat of drone strikes has forced Russia to divert air defense systems from the front lines to protect strategic infrastructure. The S-400 batteries that should be covering Russian forces in occupied Ukraine instead sit around refineries or munitions compounds. This creates a strategic dilemma that Russia can't readily solve. Protect the refineries, and Russian forces at the front lose air defense coverage against Ukrainian drones and aircraft. Protect the front lines, and the refineries will burn. With Ukraine producing 200 FP-1 drones daily, Russia faces this choice every single day with no good options. But to truly understand why the FP-1 represents such a revolutionary development, we need to compare it to other long-range strike systems that various nations have deployed. Let's start with the Iranian Shahed 136, which Russia has used extensively throughout the war. The Shahed costs between $20,000 and $50,000, flies at speeds of up to 110 miles per hour, and delivers a warhead of approximately 100 pounds. It's effective, cheap, and has forced Ukraine to develop entirely new defensive strategies. The FP-1 costs slightly more at $55,000, but delivers more than twice the warhead capacity at 250 pounds and flies at speed sufficient to reach targets 1,000 miles away. More importantly, Ukraine manufactures them domestically at scale, eliminating supply chain vulnerabilities and allowing for rapid iteration based on combat experience. And Western alternatives are even worse in some regards. The American Switchblade 600 loitering munition costs approximately $70,000 to $80,000 per unit, but has a range of only 25 miles and a warhead of just 65 pounds. The British Brimstone missile costs roughly $150,000 per unit with a range of under 15 miles. Even the more sophisticated Turkish Kargu 2 loitering munition, which cost around $80,000, has a range of only 6.2 miles. The FP-1 isn't just cheaper per unit, it delivers dramatically more strategic reach per dollar spent. For the cost of 2 Brimstone missiles, Ukraine can manufacture 5 FP-1 drones capable of striking targets over 1,000 miles away. For the cost of a single Tomahawk cruise missile at $2 million, Ukraine can produce 36 FP-1 drones. Even more revealing is the comparison to Ukraine's own alternative systems. The Lyuty long-range drone, developed by Ukroboronprom, reportedly cost around $200,000 per unit, roughly 4 times the FP-1's price tag. While the Lyuty may have some additional capabilities due to its multi-role design, the FP-1 success rate suggests those additional capabilities don't meaningfully improve mission effectiveness against the targets Ukraine actually needs to hit. This cost differential allows Ukraine to adopt tactics that would be unthinkable with more expensive systems. With Tomahawk missiles at $2 million each, every launch requires careful target selection and extensive intelligence gathering to ensure the target justifies the cost. With FP-1 drones at $55,000 each, Ukraine can afford to take calculated risks. They can strike targets of opportunity, conduct follow-up attacks to finish off damaged facilities, and even use drones for reconnaissance by fire to identify concealed air defense systems. The production methodology that enables these economies represents a complete inversion of how Western militaries think about weapons manufacturing. When the Pentagon develops a new weapon system, the process typically involves years of requirements gathering, competitive bidding, prototype development, extensive testing, and gradual production ramp-up. Firepoint went from concept to producing 200 drones per day in less than 3 years. They achieved this by embracing principles that would horrify traditional defense contractors: use commercial off-the-shelf components wherever possible, prioritize speed of production over perfection, accept that some drones will fail, and iterate rapidly based on combat results. This approach only works because Firepoint can test multiple drones every day in actual combat conditions. When a batch of FP1s encounters new Russian electronic warfare systems, Firepoint's engineers see the results within hours. They modify the software, test the changes, and deploy improved versions within days. Traditional Western acquisition processes take months or years to implement similar updates. The distributed manufacturing capability provides another crucial advantage. Defense Express reports that Firepoint uses multiple production facilities, making the manufacturing capacity highly resistant to Russian strikes. Even if one facility gets destroyed, others continue production. Compare this to Western cruise missile manufacturing, which typically relies on a small number of highly specialized facilities that would become obvious targets in a peer conflict. But perhaps the most important aspect of the FP1's success is what it reveals about the changing nature of military power. For decades, Western military thinking has assumed that its technological sophistication provides the decisive advantage. This led to weapon systems like the Zumwalt-class destroyer at $7.5 billion per ship, the Future Combat Systems program that spent $18 billion without fielding a single operational vehicle, and the Army's Comanche helicopter program that consumed $7 billion before cancellation. The underlying assumption was that advanced technology multiplies combat effectiveness so dramatically that smaller numbers of superior platforms outperform larger numbers of inferior ones. A single F-35 can dominate airspace where dozens of older aircraft would struggle. A single Aegis destroyer can engage threats that would require multiple conventional warships to counter. In low-intensity conflicts against technologically inferior opponents, this assumption held. But Ukraine's experience suggests that in high-intensity peer conflicts with sophisticated opponents, this logic breaks down. The problem isn't that advanced systems lack capability. An F-35 is undeniably more capable than any fourth-generation fighter. The problem is that advanced systems can't be produced, maintained, or fielded in sufficient quantities to matter when attrition rates are high and targets are plentiful. Consider the strategic situation Ukraine faces. Russia operates thousands of military targets spread across a territory spanning 11 time zones. Command posts, ammunition depots, logistics hubs, airfields, rail junctions, fuel storage facilities, repair workshops, training centers, and hundreds of other targets all contribute to Russia's war effort. Destroying or damaging these targets degrades Russian military capability and forces them to expend resources on repairs and reconstruction. With Tomahawk missiles at $2 million each, Ukraine could theoretically strike 500 targets if the United States provided $1 billion in cruise missiles. That sounds significant until you realize Russia has thousands of military targets. Even if every missile hits its mark, Russia would simply absorb the losses and continue operations. The strategic impact would be limited. With FP1 drones at $55,000 each, the same $1 billion could theoretically produce 18,181 drones. Even assuming significant losses to air defenses and operational failures, this represents enough strike capacity to hit every significant Russian military target multiple times. Now, the strategic impact becomes overwhelming. Even with conservative estimates of air defense effectiveness, the relatively high production rate translates to hundreds or potentially thousands of successful strikes monthly. No military can sustain that level of attrition against critical infrastructure and maintain offensive operations. The implications extend far beyond Ukraine. If a relatively small country under active invasion can develop and field long-range strike capabilities that rival or exceed those of major powers, we might see the concept of future conflict shift dramatically. The FP1's development also illustrates how Ukraine has become a testing ground for the future of warfare. Firepoint developed this little drone through thousands of combat missions, constant iteration based on battlefield results, and sophisticated engineering to defeat Russian countermeasures. The drone's thermal signature management, navigation algorithms resistant to GPS jamming, and structural designs optimized for mass production all represent cutting-edge developments. The company's decision to develop its own solid propellant for booster launches particularly highlights this innovation. Solid fuel boosters provide crucial advantages for dispersed launch operations. They don't require complex fueling procedures, they can be stored for extended periods, and they enable faster launch cycles. But developing solid propellant requires specialized expertise in chemistry, material science, and manufacturing safety protocols. Defense Express reports that this breakthrough has positioned Firepoint to develop ballistic missiles. This represents a massive escalation in capability. Ballistic missiles follow very different trajectories from cruise missiles like the FP-1, making them much harder to intercept. They also deliver warheads at much higher velocities, increasing kinetic impact. If Firepoint can produce ballistic missiles with even a fraction of the efficiency they've achieved with the FP-1, Ukraine would possess strike capabilities that rival regional military powers. But beyond technical capabilities and production numbers, the FP-1's greatest impact might be psychological. For over a decade, Russia has positioned itself as a military superpower with sophisticated weapons systems and the industrial capacity to sustain prolonged conflicts. Russian propagandists regularly mock Western weapons as overpriced and ineffective. They claim Russian air defenses can shoot down any threat. Yet, here's Ukraine, a country with roughly one-third of Russia's population and a fraction of its military budget, producing 200 long-range strike drones daily and successfully hitting targets throughout Russian territory. Russian air defenses haven't stopped the attacks. Russian counterstrikes haven't destroyed Firepoint's production facilities. Russian electronic warfare hasn't prevented FP-1 navigation. Every successful FP-1 strike sends a message that Russia's air defenses aren't impenetrable, its strategic infrastructure is vulnerable, and Ukraine possesses the industrial capacity to sustain this campaign indefinitely. This also affects international perceptions of Russian capabilities, investor confidence in Russian industries, and domestic Russian support for the war. This brings us to perhaps the most important question: what happens next? Firepoint is already producing the FP-2, a similar platform optimized for strikes at over 125 miles away with a 220-pound warhead. This fills the operational gap between tactical drones like FPV systems operating at ranges under 15 miles and strategic systems like the FP-1 operating at hundreds of miles out. The FP-2 provides Ukrainian forces with the ability to strike Russian positions, logistics hubs, and command posts throughout the entire depth of the occupied territory. The company has also unveiled the FP-5 Flamingo cruise missile, though details remain limited. What we do know suggests Firepoint is applying the same mass production philosophy to more sophisticated systems. If they can achieve even a fraction of the FP-1's production efficiency with cruise missiles that have longer ranges, larger warheads, or advanced guidance systems, the strategic implications become enormous. But the real question is whether other nations will adopt Ukraine's approach. The FP-1 demonstrates that mass production of simple systems can defeat smaller numbers of sophisticated platforms. This suggests that the entire Western model of military procurement might need to be reconsidered and rebuilt from the ground up. Instead of spending billions on small numbers of exquisite systems, perhaps nations should invest in production capacity for larger numbers of adequate systems. And this isn't just a theory either. Several European nations are already examining Ukraine's drone programs with intense interest. Poland, the Baltic states, and Nordic countries all face potential threats from Russia and are actively seeking cost-effective defensive and offensive capabilities. The FP-1 offers a template: identify the actual mission requirements, strip away unnecessary complexity, optimize for mass production, and iterate rapidly based on real-world results. American defense contractors are watching nervously. If the Pentagon decides it needs 10,000 long-range strike drones rather than 500 cruise missiles, That represents a fundamental shift in procurement priorities and contracts worth hundreds of billions of dollars. Companies optimized for producing small numbers of sophisticated systems will need to completely restructure for high-volume manufacturing. But there's also a darker possibility. If relatively small nations like Ukraine can develop these capabilities, so can others. Iran is already producing thousands of Shahed drones annually for export. It's not entirely out of the realm of possibilities that it can further improve on the design. For Russia, the implications are potentially devastating. The country is fighting a war where their opponent can strike strategic infrastructure throughout its territory, and the economic cost of defense exceeds what Russia can sustain long term. Every air defense system protecting a refinery is an air defense system not protecting troops at the front. Every ruble spent on repairs is a ruble not spent on ammunition or weapons. Every percentage point of refining capacity destroyed is billions in lost export revenue. And Ukraine isn't slowing down. Firepoint continues to expand production capacity. Other Ukrainian companies are developing their own long-range systems. The Ministry of Defense is refining targeting priorities and battle damage assessment. Ukrainian forces are learning which targets provide the most strategic value and which are vulnerable to drone strikes. As one Firepoint engineer explained it, "We're not trying to make the most advanced drone in the world. We're trying to make enough drones to win the war. There's a difference." And that difference might just determine who wins this conflict and shapes the future of warfare for decades to come. Thanks for watching. To see how Ukraine continues to innovate against overwhelming odds, check out our video on the Mongoose interceptor drone that's revolutionizing air defense. And to stay updated on critical developments in global military technology, subscribe to The Military Show for daily analysis.